Okay, in the end of the previous video, I showed that the least common multiple or the least common divisor of these two should be an algebraic one. But how could we find that? Now let me explain it for two general fractions, a over b plus c over d, and all of them are polynomials. Not all of them, but at least b and d are polynomials. Okay, now the least common multiple or divisor of b and d is a polynomial which is divisible by both of them, but is of the lowest possible degree. Let's show the least common divisor by L. So L should be divisible by B. That means that L should be equal to B times another polynomial or factor. Let's call that B prime, and L should be also divisible by D, so should be D times D prime, another polynomial. Now let's write B and D in terms of their greatest common factor, and let's call that by G. So B should be equal to G times B1, say the greatest common factor of B and D times another factor. This is B, and D should be equal to the greatest common factor G times another factor. Let's call that D1, D prime. Okay. Now the least common multiple should be divisible by G first, so it should be equal to the greatest common factor also B1 let me to the greatest common factor times times B1, because G B1 equals to this is G B1, and D equals to G D1. So L should be divisible by both of them, and at the same time of the lowest possible degree. So it should be equal to G also contain B1 and also D1. and this is the lowest common multiple because it is divisible by b, also divisible by d, and is of the lowest possible degree. And if you remove any of these three, then in order to make the degree of L lower, then L would not be divisible by B and D. Okay, so in order to find the least common multiple, you should find the greatest common factor of the denominators times the rest of the factors of the denominator. Okay, let's go on with the example, but let's change the denominators a little. This is -2 and this is -2. And let's write these here. Okay. Now the strategy here is to first find the greatest common divisor. We could use the linear combinations method, but we could easily factor the denominators. This is x squared. If we take x squared outside of these two, this is x squared x minus 2, and this is minus x minus 2. So this is x minus 2 times x squared minus 1 and we could also factor this, but I have a reason not to factor it. How about this one? This is also the same as this. Take x squared of these two, x minus 3, and this is minus x minus 3. So this is x minus 3 times x squared minus 1. So what is the greatest common divisor of these two? This is x squared minus 1, right? So here g is x squared minus 1, and now what is b1 here? B, this is b and this is d. Okay, so g times b1 is this. This is g So this is b1 x minus 2. Also this is g and this is d1, and the least common multiple is x squared minus 1 b1 x minus 2 times x minus 3. Easy peasy. Okay, and in order to make the denominators equal, the denominator, the same denominator should be this, the least common multiple, and this is this, and this is this, and in order to make it equal to this, we should multiply it by x minus 3, and in order to make it equal to this, we should multiply it by x minus 2, and also the denominators. So you could do it for practice if you like. Let's